arctan x arise in specific integrals, right? So we're gonna be looking at this two, where we're gonna say that for the arc sine we have to decide, or we have to know, is it a squared? Remember, you're going to be looking at this two. We must look at this two. It's this one, and also it's this one, and then also it's this one. You see, right? So these two, they only differ because here we are subtracting the a, here we are subtracting the x. So we need to know which one is the arc sine, which one is the tan, and which one is the sec, right? So I think I have some of the examples here that we are going to use. So I think I have some of those examples. Let me see. Yeah, I think these ones are fine, but let me try to send these other ones in the group, right? So you can see them. Or let me just try to write them here. I have these. Yeah, so this is taken from this, right? We have these ones at the first one. We remember these ones from the trig u substitution, right? From the trig u sub, we had this one of a squared minus x squared, the ones I was writing up there, right? Then this one, we know that we're going to set x to be equal to a sine u. And then when we have this one of a squared plus x squared, we're going to be setting x to be a tan u. And then when we have x squared minus a squared, we're going to be setting x to be a sec u. If we check from here, if I'm dealing with the first one, if I'm dealing with this one and I'm looking for the inverse, right, sine, for the inverse sine, it means that I'm going to say here that x is equals to a sine u, which this implies that x over a is equals to sine u, and this implies that if I introduce the arc sine both sides, I'm going to have that u is equals to arc sine x over a. Right, now if we check, if now I take this, let's say not necessarily take this, but 1 over this. If I take 1 over this, you see, right, 1 over this, and integrate it, I'm going to get the arc sine x over a plus a. So always when we forget this, we're going to use this so that you don't cram, right? If you forget this theory or you forget this property, you can just come and use this one to say that I know I can drive this. When I drive this, I can drive it to this. So I know that if I can integrate 1 over a squared minus x squared, and then I'm going to get the arc sine. You see, right? So this is what you're going to get. Now, if we look at the one for the arctan, the arctan, remember, it comes from here, right? So it means that the one for the arctan, we can also drive this one. Now, when we drive this one for the arctan, there will be a bit of a difference here, right? But I'm going to explain this also. So if we drive the one for the arctan, we can have xa tan u, and then this will be x over a, which is also tan u. Then this will be u is also arctan x over a, and then I have to multiply this one by 1 over a, right? So this can also assist us to check that, right? And then from here, what you're going to, if you can check also this one, it was multiplied by 1 over a. So these two are always going to be multiplied by 1 over a. But we can also take it back to the theory which is in the guide. We're given this theory. We shall go to the guide now. Then we'll look at the theory in the guide, and then we'll try to associate. Sometimes they are both going to assist us, right, when we come to a difficult situation. So let's first start by looking at some examples in the guide, and then we'll take it from there. Then we'll go back to the ones in this slide. So for the ones in the guide, I think yeah, if we can check, this is what I was talking about first, right? Remember from the trig substitution, we go to the trig inverse. So we remember these functions. First, we need to remember these functions, that when x is the one which is subtracted, we get sine, we get a sine. When a is the one which is subtracted, we get sec. And when these two are added, we already know this one is tan. So now from this part, we now come to, I think it should be somewhere here, right? The integration of inverse trig functions. What we were saying that time is that if we're looking at here, when we're having a squared minus x squared, remember we said that this is going to be x over a, x sine x over a, right? Remember, this will always, sometimes will change, it won't always be 1. So that's why here we got x sine x, because we know already that this should be x over 1. You say, right? Then we get this solution. So this is still the same thing as coming here. I write that the integral of this one. If I introduce the integral here, then dx. Also here the integral, then dx. This integral will take care of this. You say, right? So we're going to get that 1 over root of 1 minus x squared dx is equal to x sine x over 1. So we need to get use of this format, right? Now, when we come to this, let's see another property. Which is this one here. Let the root it here. Let me erase this one. I think the root it here. And then, now when we come to this one of arc cos, right? The arc cos is still the same as the one of the sine, but the only difference, remember when we derive cos, we get a negative sign. You say, right? So, and this is the one for the arc sine. So this will just be negative, the same function. So this one you must always know is the same function, right? It just comes with a negative. So same function, but comes with a negative. Now, for the tan, already we know that for the tan it's gonna be 1 over 1 plus x squared. Remember here, I said that the integral of this, let me write it here, the integral of 1 over 1, this one is like this. If it's, let's say not 1, let me just say x a squared This thing doesn't allow me to write. Oh, it's a squared plus x squared dx. Remember, if I introduce the integral both sides, I'm going to get this, right? Which this will be equal to the arctan. This will just be x over a. Then here, remember, we have to put 1 over a. I'm sure we agree with that, right? Now, if now we come and say that, let me erase this. Now, if we come and say that this, if we check, this is arctan. Here, there's no, here it means that our a is 1. You see, here our a is 1, right? So already here a is 1. That's why here we have 1 over 1 tan arctan x. So you should always know that this won't always be 1. Sometimes it will change. You see, right? Sometimes it will change, so you must just get used to that. And this will happen if we come to this one. This is the one which I included there. The only difference between these two is just the same as the sine and the cos. The only difference is the sign. You see, right? If we go back to that slide, let's go back to that slide. The slide is here. So let me erase this. If we go back to the slides, we realize that these are the properties that we should know, right? So we know that if I'm dealing with this one, 1 over a squared plus x squared, the integral of that will take the arctan x over a, then we multiply it by 1 over a. You see, right? Now, when we come to this one we're going to say that if I have 1 over x root of x squared minus a squared. Remember, this one of x squared minus a squared is coming from the sec, right? If we go back here, we see for the arc sec, we have x squared minus a squared times x outside, which is this one in this case. You see, right? This one is coming from the sec, though it can be simplified in detail, right? If we can check, it's coming from the sec, right? As long as a is the one which is subtracted, then we multiply outside by x, which here they say here that this is equal to, we can check, sec, this is sec x plus c, just because we're integrating. But check there, if this was a, here we're going to have 1 over a. We're going to have 1 over a here, and here over a, something like that. You see, right? But in this case, if we see here, also it can be written in this format. That's why I tried to include this format. Let me say, it can be written in this format. What's happening with this document? The document is no longer reading, right? I don't know why it's no longer reading. Let me just to open it here. I think if I can open it here, it will be fine. Yeah, then I'll just try to open it here. I'll just be moving around the two documents, right? So from here, let's check. So I want us to take this into detail. We're going to take this two. Everything that we'll be solving, we'll be looking at this. Remember, I said that this one of the arc sign. Remember, this can also be written as. This can also be written as let's say 1 over a arc sec x over a. Right? This can also be written like this. So now we say this, that if this is 1, then this will just be 1 over 1 x sec x over 1 plus c. That's why there we got this. So you'll see when we are proving most of the things that it's going to be that simple. So let's go and look at the examples now. I think it would be much better if we just look at the examples and then we explain, right? So let's look at the first example. The first example, they say we should find the integral of dx over 4 plus 9x squared. So first we need to change this denominator into something like this. Remember, this denominator is between these two. These are the only ones without a root. You see, right? Now, when we come to change it, remember I said this. I said that first, what we need to do here, we need to do this. We need to say this is the integral. We need to change it to that. We need to say this is the integral of dx over. Now, there are many ways you can solve this, right? You can start by saying this 2 squared plus 3x squared. You can first start by putting it in this format. And I told you before that this is just going to be like this. We're going to say that this is equal to this is going to be arctan. This is going to be our x here. In this case is 3x over our a. Our a is 2. You see, right? Now if you can check, it's the same as this one, right? This one, it was 1 over a, but this will always change based on what do we have inside here. What is our angle? Remember, this was 1 over a, but since our angle here is 3, that 3 is going to affect it. If we come and check, it will be 1 over 6. So if we come in, that angle comes and affect it. Let's say we get 1 over 2 times 1 over 3. Arctan 3x over 2. So you can easily confirm your solution, right? Then you see that this will be 1 over 6. Arctan 3x over 2. So now let's go through these procedures. Then we'll see how we can the alternative way we can take it, right? Now, the alternative way is to make sure that you have a 1 here. Here. And the alternative way is to make sure that you always have a 1 there. So this is the reason why they factored out a 4. You see, right? Because you don't want that 4 there, you need a 1 there. So we're going to factor out a 4 in this 2. When I factor out the 4, I'm going to get this. Now, the aim is to now change this to everything squared. You see here how I changed this. I changed this one to 3x squared. So I have to change everything to squared. I change it to squared. And then, after when it's changed to squared, now I can come and apply what I know, right? Now, what I can do is this. Since we know that we can do this, since the angle here, it's no longer x, it's affected. Now we are told that we are supposed to come and multiply by a 1. So we're going to come and multiply by this, which is inside. So this is the trick that we're going to be using always. It will assist us in having this angle out there if you want to integrate this, right? Remember, for you to integrate this, you're going to do this. For us to simplify this, you're going to use substitution here, because you only want x here, right? So we're just going to let this to be u. So we're going to do this. We're going to let u be equals to 3x over 2. Then when we derive this, we get 3 over 2 dx. Then we make dx up with the formula. We're going to get du 2 over 3 is equals to dx. Then we come here and substitute. When we come here and substitute, we're going to get 1 over 4 integral of 1 over 1 plus u squared. Then this is 2 over 3 du. Then this will come here. It's going to be 1 over 4 times 2 over 3. Alright? The integral of 1 over 1 plus u squared du. And this one, we know that it's arctan u. And this 2 over 4 is going to give us 1 over 2. 1 over 2 times 1 over 3, it's going to give us 1 over 6. Then we add the c. You see, right? This can be the easiest, but if you want to avoid this u substitution, I told you, you're just going to come and multiply this. You come and multiply by 3 over 2, and it's inverse. You see, right? Like this. Now you multiply by this, then you distribute. You see, right? Now, so we can also try to look at this question in 2 ways. So let me just erase it, and then we go and look at it in a way that we look at it in 2 ways, and then we analyze it. Remember, the original question is saying dx over 4 plus 9x squared. Dx remember the question say this, the integral of dx over 4 plus 9x squared. Remember, I said that what we need here, want to put this in this format. 1 over 1 plus x squared dx. Want to put this in this format. Our target. You see right now? This is our goal state. So, since we want to put this in this format, we already know that this 4 must go. So we're going to factor out a 4 in both sides. Here. We drop that dx. Then this will be equal to the integral, or let me take out this 1 over 4. This will be the integral of 1 over 1 plus this one. I said that we can change it, right? So that we can only have a squared. This is 3 over 2. This is x squared. Everything squared here. Now we say that this is in this format. But remember that the constant here is 1. So we're going to multiply here by 1 times 1 times 1. You see, right? So this is the trick that you're going to be using always to avoid your substitution. As long as this angle here is not 1, we're going to come here and say this, and say that this is 1 over 4. The integral of we're going to come here and multiply by this. First we initially multiply by 3 over 2. 3 over 2 times 2 over 3. It's like I'm changing this 1 to this. You see, right? Now this is 1 plus 3x over 2 all squared dx. Now we're going to take this one, which is the opposite of this, and multiply it with this one. Then leave the other one. You see, right? We leave this one. This one will just be there. It won't affect us anyway. Now, this will just be equal to, this is 1 over 6. Then this, remember, if this was 1, this will be 1. So that will just be an angle. This will just be an angle inside. So this will be arctan 3x over 2 plus c. I'm sure we see this, right? Now, this is the only trick that you're going to apply here. When you come to here, you're just going to change 1 to this. Then you take the one which is the opposite of this angle, you multiply it with this one here. Then you get to the solution. Now, let's look at a problem there, which has a similar approach, right? Let's look at the problem. We have this problem now. The integral of 1 over 1 plus 9x squared. Let's write it and see if we'll get this. This will just be the integral of 1 over 1 plus 9x squared dx. Already we know that we want this thing to be in this format. Right? Let's say this format. So let me say 1, because we wanted this to be arctan, right? Now, we come and say, for us to have that, remember I said that already this is 1, so I'm just going to change this. So everything can be squared. Then this will just be 1 over 1 plus 3x all squared dx. Remember I said that if there's an angle here, the next step is to change the numerator to that. You multiply by its inverse. The inverse of 3 is 1 over 3. You say you're just going to change 1 to that. This is 1 plus 3x squared dx. And then the 1 over 3 will be dropped here. Then the 3 will remain here. Remember I said that this won't affect us, it's just an angle. It will just represent an angle there. So this will just be 1 over 3 arctan 3x plus c. You say, right? Now it's that simple. We get the same solution as this one. So let me see if we still have another one for arctan. We have this one. Right? Where they say that this is going to give us 1 over 2 arctan x plus 1 over 2 plus c. So it means that here we have to apply, the moment we see this type of a question, we have to apply completing the square. So we have x squared plus 2x plus 5. Let's go do it. X squared plus 2x plus 5. Now remember, we want this thing to be in this format. As long as there's no minus here, guys, we are forced to have this thing in this format. So meaning that we have to complete the square here. You say, right? So if we're going to apply completing the square here, this is just going to be x squared plus 2x plus 5. Now, who can tell me, can anyone remind us, how did we apply completing the square last time? How did we apply completing the square last time? Yeah, I think I did show you guys how to apply completing the square. I think it was here. Even I think I showed you multiple examples, right? Yeah. Yeah, the examples. I showed you multiple examples. I think about, let me see, how many? One. There's this one, which we completed the square. And also, I think I did many here, as much as I remember. I don't know if I wrote them here or not. I think I erased them. Yeah, but it's fine. I erased them. So we can complete the square for this one, right? Remember I said that you're going to pick your b. Your b is this one. So you're going to subtract and add by b over 2, the coefficient of b over 2 squared, plus that same coefficient of this squared. You see, right? Now, this is x. Let me plug this. I think it's running low. So This is going to be x squared 2x plus 5 minus 1 squared plus 1 squared, right? Dx. So I'm interested in this too. I'm sure you remember that, right? Say that I'm gonna be interested in this too. So what are these gonna give us? Anyone to tell us? So this means that we're going to get this, right? We're going to get 1 over x minus 1 all squared plus 1. Is this what we're going to get, guys? Let's try to expand it and see if it's going to give us the answer which we want. Let's see, I think is it plus, let me see if I forgot something, x squared minus 2x. Oh, this is plus. I'm going to take the positive one. And let's see, x squared plus 2x plus 1. Then if I take the positive one, this one will be negative, right? Then I have that plus 5 here. I forgot the plus 5. So this is just going to be minus 1 plus 1, then plus 5. Yeah, which is going to take us back to the same thing, right? Now, if we have this is going to be the same as 1 over, let's take this one, this side, it's going to give us 4 plus x plus 1 all squared. Now, what can we do here? Remember, we want this to be 1. So we're going to factor out 4 in both sides. One plus x plus 1 squared all over 4 dx. Now from here, we take out the 4. 1 over 4 outside. 1 plus, now we now want everything to be squared here. So it's just going to be x plus 1 over 2 or squared. So it'll take us back, right? Now remember I said that if we have a constant here, we have to come and multiply by that constant. But now things changed. Do we still have a constant? Is this a constant? Who can tell me, how can we work around this one? This question. Now if you can see, now things changed, right? Now we have x plus 1. So that's why I decided to include this question. It won't always be a constant. Now we have x plus 1. Who can tell me, how can we deal with this question? Because if it was a constant, let's say this was just over 2. We're just going to come and multiply by 2 times 1 over 2 here. And if it was 3, we're also going to do the same thing, right? So how do you think we're going to answer this question? Okay, tell me, what are we going to multiply with here? Guys? Okay, since there's no one to tell us, let me show you that. So what you're going to do here, you're just going to come and multiply by, you're going to consider this constant. You're going to ignore this one, right? You'll consider this 1 over 2. The constant there will just be 1 over 2. If you divide here, for the x, you're going to get 1 over 2, right? So it means that you're going to come and multiply by 1 over 2 times 2. Then this one is also here. You took it here, so you're going to leave it. And then you leave it there, and then you put the 2 here. Because remember, when I drive this, I'm going to get 1 over 2. So that 1 over 2 is fine there. So here I get 1 over 2. And this will just be arctan x plus 1 over 2 plus c. So if we go back there, we check, what did we get? It's the same thing. Let's see. think it's this. Yeah. It's this, right? So I'm just gonna, let me just highlight all that we have done. Since now we're only doing the ones of the tan. Yeah, I'm just gonna highlight these ones. Now we have this one where they say we have the integral of 4 plus x squared, 1 over 4 plus x squared. Now if we look at this, I want you to try this one, right? This one will be simple, will be very simple to do. You're just gonna come here and change. This will be the integral of 1 over 2 squared plus x squared dx. Already we changed this to everything one, but remember this, we're not looking for this, so we're not gonna use this approach. Remember, that's also an alternative approach, right? But it needs you to know the original formula. So here we're just going to factor out the 4. I think I enjoy this one more because you get to apply everything that you're working with. So this will just be 1 over 1 plus x over 2 squared dx. And remember I said that once you come here, you recognize your constant inside there. It means the one which has x there, it means that you're going to come here and multiply by that constant and its inverse. Now this inverse will come and multiply by 1 over 4. Then we get 1 over 2 outside. And then this will just be arc of x over 2. I'm sure you see this, right? So this will take you to your solution. So I'll take it as we have done this question also. So if you can check, guys, I believe that there's no way they can bring a question that has to do with tan and you get it wrong. There's no way, right? So all the questions for tan, I think we're done with them. So you're just gonna come and try this. So you'll try this one. Let me see what else. You try this. You try this. I think we've done this one. I'll only try this. Yeah, also this one. Try this one. Yeah. So these are 4 that you're going to try, right? Now, let's go back and we look at the other examples that we have. Now we're going to focus on the ones that have to do with arc sign, right? So we'll focus on the ones that have to do with arc sign. Let's say this one, it's arc sign. Yeah. So remember with arc sign, guys, arc sign, we know what is it that we must focus on. Arc sign, we must change everything as long as we see that so here's how we know we're going to deal with arc sign. If your x has a negative, you say, right, you know already that you're going to be dealing with arc sign. So let's look at, let me see, I think, do we only have this example here? Yeah, you see, if your x is negative, you know you're going to focus on arc sign. If your x is negative, you focus on arc sign. X is positive, focus on arctan. And then x negative, arc sign. It will be simple for you to do this. Once there's an x outside, you know you must focus on sec and cosec. You see, right? This one, if there's a negative here and a negative outside here, you're going to focus on arc cos. But initially, the one which we're interested in is the arc sign. So I'm interested in the arc sign. I'm interested in these 3: arc sign, arctan, and the arc sec. These are the ones which I'm interested in. You see, right? This one can give us the arc cos. This one can give us the arc cos. this one can give us the arc cos. This one can give us the arc cot. This one can give us the arc cos cot. Then this one the arc cos. So let me just say this. If there's a negative there, it will give us this. If there's a negative on this one, it will give us the arc cot. The arc cosec, man. Not the arc cot. Arc cosec. Right? Now, already, this tells us what the arctan can give us. If we go back to this, the arctan, if there's a negative, will give us the arc cot. The arcsec, if there's a negative, it will give us the arc cosec. Then the arc sine, if there's a negative, it will give us the cosec. So you only need to know 3. Then you know that its negative is going to give you this one. You see, right? So it's not that difficult. Now let's look at the one for sine. The arc sine. We know with arc sine, we must change everything to 1 over 1 minus x squared dx. So if we have this, we must complete the square. But before we complete the square, we can't complete the square where x is negative, right? We must change the x to be positive first. We can do that. We can factor out the negative, right? So first we start by factoring a negative out here, which is this. Then after factoring out that negative, then we apply inside there, we complete the square. So remember, if we come and complete the square here on 6x, I'm just going to come here and add 6 over 2 squared minus 6 over 2 squared. Then I'm going to get 6x plus x squared plus, as we're not going to change it to 9, right? Plus 3 squared minus 3. We're just going to keep it like this, squared up until it's necessary, right? And we know that outside we have minus 5. So when we have this, what we can do from now on is we ask ourselves, are we looking for sine or tan or sec, right? Now we're going to have this. Since there's no negative on top and we're looking at the negative here, we see that at the negative we're looking at the sine, arc sine. So already we know that this will be, so this is just gonna be, let me put it like this, 6x, your x squared plus 6x, then this is plus 3x squared minus 3 squared. We wanted this one because this is positive, because this sign here, this one is positive, the middle one is positive, so we're going to take this one off, which is positive. You see, right? Now here we're going to have x plus 3 all squared. Then this one we can just say minus 9. Now since it's minus 9 and we know there's a negative here, so this will just be minus 5 minus, then this will be minus 5 plus 9 minus x plus 3. Always, if it's arc sine, we're going to keep the constant here. Even if it's tan, let's just keep the constant there, unless if it's sec, right? That's going to be a different story. Now this will be 4 minus x plus 3 all squared. Now this is this. Now we get here. Now we see how we completed the square, right? When we are here, we want this to be 1. You see, remember our goal, our aim is to make sure that we change this to that format of arc sec. You see, right? So we need to remember that. Let's not forget what we're looking for. It will be simple for us to do everything if we know what we're looking for. Now, we know we're looking for this, right? We come and factor out a 4, which is this. Then we change this 4 to this. Now, remember how we got the 1 over 2. Remember with 1 over 2, I said that first we're going to take out 1 over 4, right? After taking out 1 over 4, here we're going to multiply by 1 over 2. I said we'll ignore this 3. Multiply by 1 over 2 times 2. Now, this one will come and multiply by 1 over 4. We get 1 over 2. Then we ignore this 1 over 2 up here. Then we just take the arcsec of this without using U substitution. You see, right? So the solution here means that it's going to be solution is going to be the arc sine of x plus 3 over 2 plus c. I'm sure we see this, right? So now since we know this, it will be simple for us to work around it. So now let me see. Yeah, it will be simple for us to work around this. Now we know that this is going to be, without using this substitution here, this is what we're going to get, right? Now let's say this. Let me see. Let me see. I think when I was explaining this one, I might have forgotten that this is a root, right? So it means that this one, let me just write it here without saying, because I might lose a lot of people. So if I take this one out, I'm going to take it as a root of 2, right? So your root of 4. Now I'm going to be left with this. Let me just write 1 here. 1 minus x plus 3 over 2 squared dx. Remember this one here, we're going to change it to, as I said, 1 over 2. We'll ignore that 3 there. We just take 1 over 2 because it's the constant which goes with x times 2. So this is going to be 1 over 2 here. This 2 will come here because it's not corresponding with this, right? So we're going to take that 1 to come there. X. Now this will cancel out. We'll be left with the integral of 1 over 2 all over 1 minus x plus 3 all over 2 all squared dx. Now this will just be the arc sine x plus 3 over 2 plus c. You see, right? Then this will be the solution. So these are as simple as that, guys. It's not difficult. As you can see, the one of the arc sine should also be simple for us to work with. So they're as simple as that. So I'll request you guys to try and do the other ones. It means that on our next session, we're going to look at the last part. I'm going to stop here, right? We'll look at this one. And then after looking at this one, then we'll look at, I think, then I'll send the other slide, but I'll request you guys to do the last parts of the problems which are sent. These problems which are sent, I said that you can try. Let me say here. Then it means that on our next session, we'll finish the one of the arcsec. Then we do the definite integrals. Then we look at, from the definite integrals, they also come with the area and the arc length. Yeah, so we'll see that. Now, let me see. This is what I want you to try now, right? So far I say that we did these ones where we subtract x. Yeah, this one. Go try this one, right? But I can say that we also did something like this, so it's not that difficult to try. This one we did, I was explaining one like this. So let me see. On the problems, I want you to try this on the problems. On the problems, I want you to try this, where we are subtracting x. I want you to try this. Try this. Try this. Try this one. Yeah, I forgot to say try this one. Yeah, that one is also, it falls under. Let me see. What else can we try? Try also this one. So you can try these, right? So make sure to try these, guys. And then after trying these ones, trust me, you are almost halfway. You are good to go. If you can try this and get them. So make sure after getting these solutions, you send them. You can send them in the group, or you send them to Manel, right? The one which I tagged in the group. And then you'll look at this. And then if anything is let me say difficult, or maybe you don't get a reply as fast as you can, or as fast as you expected it, you can just tag us in the group, then we'll attend to you, right?